Hi, and welcome back. In this lecture, we'll dive into the final stage of expansion processing, which is file name expansion or globbing. It is performed after word splitting. There are three characters that perform globbing: star or asterisk, question mark, and the square brackets. If one of these characters appears and is not quoted, then it is considered a pattern and replaced with a list of file names matching the pattern. Let's take the globbing special pattern characters one by one. Star or asterisk is the most commonly used globbing character and matches 0 or any number of characters. It matches emptiness too. So if I run ls star, it will list all the files and directories in the current directory because star means anything. For the next examples, I'm gonna create some files using two brace expansions. So touch F A double dots C, and a second brace expansion, 1 double dots 10 .txt. It expanded A double dots to A, B, and C, and 1 double dots 10 to 1 to 10. So it created 30 files. And I'll create one more file, simply named F. Touch F. Let's list all the file names starting with F. ls F asterisk. We see that it listed all the files that started with an F. Note that it listed the file called F2 because star matches emptiness as well. And if I wanted to list all the file names starting with FA and ending in .txt, then I would run ls fa star .txt. Note that file name expansion is performed only if the special character star, in this case, is unquoted. So if I quote it, it will not perform the expansion, but rather try to list a file literally called fa.txt. It didn't perform the expansion, but tried to list a file called fa_star.txt, and there isn't such a file. Note that file names starting with a dot are not matched by the asterisk. So touch.abc. This is a hidden file. And ls star .abc was not displayed because the dot at the beginning of the file name was not matched. A dot must be matched explicitly like this: ls.a star. Okay, that's it for the special character, the asterisk. Now let's move on to the second special character, which is the question mark. Unlike an asterisk, which matches 0 or any number of characters, a question mark will match any single character. Let's say we run the command ls fa question mark .txt. We read the pattern as fa, then any single character, then .txt. And I got all the files that have exactly one character between a and .txt. fa10.txt was ignored because it has more than one character between a and .txt. If you want to match it to, you could run ls fa question mark .txt. It will match any file name starting with fa, then any two characters, then .txt. So you can use the question mark multiple times for matching multiple characters. Now let's go ahead and take a look at the last special character, which is the square bracket. Square brackets are used to match a single character from within a range. Let's see the first example. ls fa and 1, 2, 3 between square brackets .txt. It matched all the file names starting with FA, then having a single character which is 1, 2 or 3 and ending in .txt. Note that even though there are more characters inside square brackets, it matches only a single character. In this example, fa10.txt was not matched because there's more than one character between fa and .txt. And if we wanted to match all the files having exactly one character between f, the number, and txt, as long as the character is a or b, we could run ls f between square brackets ab star.txt. This is interpreted as f, then a single character which should be a or b, then 0 or any number of characters, and then .txt. A cool feature of square brackets is that it allows us to use ranges of characters or digits. Let me show you another example. ls f a-c in square brackets 3-7 in square brackets .txt. This should be interpreted as f, then a single character between a and c, so a, b or c, and then a single digit between 3 and 7. It would be the same as ABC in the first pair of square brackets and 3, 4, 5, 6, 7 in the second pair of square brackets. It's the same. You can use ranges of lowercase and uppercase letters or digits. For example, ls f-age a-z, capital A dash capital Z, and 0-9, and a star. This will expand to file names starting with a lowercase letter between F and H, then having a single lowercase or uppercase letter between A or Z, or having a single digit between 0 and 9, and then ending in any number of characters. See the star here. And finally, I'll show you how to negate a pattern expression. In Bash, you can also negate an expression using the exclamation point or the caret symbol. For example, lsfab in square brackets star will make all the file names starting with F, then having either A or B, and then 0 or any number of characters. But adding a caret or an exclamation mark after the opening square bracket will negate the single character in the square brackets. This means F followed by any single character that is not A and B, and then 0 or any number of characters. And this one will match all the file names starting with any character which is not a digit. So if I create a file called 10.txt, it won't be matched. We used the ls command in all of these examples, but you can use globbing with any other command. For example, I'm gonna remove all the files starting with F, then having a lowercase letter between A and Z, a digit between 0 and 9, and the ending in .txt. Now, I'll tell you something really important, so pay attention. If you run a potentially dangerous command, such as rm, and you don't know exactly into what works the pattern will expand, it's a good idea to first run the echo command with that pattern. I'm running first the echo command. This way, you can check that the file names have expanded correctly and only then run the potentially dangerous command. This is how it expanded. It's okay, so I'm running rm. That's all about file name expansion or globbing. We just went over all the expansions performed by the shell. After all these expansions performed by the shell, the next step is quote removal. We'll dive deep into quote removal in the next section. Now, at the end of the current section, I want to congratulate you again. You are doing fantastic. You've just completed an important section on how the shell performs expansions. This wasn't an easy job for sure. As a short recap, there are 8 types of expansions performed in the following order: brace expansion, tiled expansion, parameter and variable expansion, command substitution, arithmetic expansion, process substitution, word splitting, and finally, the last expansion the shell performs is the file name expansion, aka globbing. We'll take a short break, and after this video, we'll start a new section about the shell operation in depth.